No question, sir.
No question. No question, then wait, okay, no question, then you read this exercise 5.8.
Find the horizontal distance the skier travels before coming to rest if the incline also has a coefficient of kinetic friction equal to 0.210. Assume that theta equal 20 degrees.
Okay. Uh, in this second question, okay, the same, this 5.8 and exercise 5.8 and exercise example 5.8, yeah, they have the same, it's the same skier, so they have the same initial velocity. Is it the same? Yeah, same initial velocity, same height, right, above the ground. But the only difference is this one. The only difference is this one. The inclined plane also has a coefficient of friction. So that means in the first case here, the slope is frictionless. But in the second case, the slope has friction. If it has friction, the velocity at the bottom here will be less. Then the horizontal distance traveled will also be shorter. Will also be shorter. So I draw a new diagram over here. I draw a new diagram over here, right? To show the situation in the second case. Okay. So I've drawn a slope here and also a certain horizontal distance here. So the slope, how much distance along the slope we don't know, but we now know that even along the slope there is a friction. So I call this frictional force F1. Along the horizontal surface there is also friction. I call this friction F2. So now we have two friction. So what happened is that according to the work energy theorem, so all the energy will be used up to overcome the two friction, the first friction and also the second friction. But before we can calculate the work done, we have to calculate the friction first lah. We have to calculate the friction F1 and F2. So now I'm going to calculate the work done, the friction F1. Okay, so we know that F1 is mu n, where mu is the coefficient of friction and n is the normal reaction, the normal reaction. But along the slope here, with an inclination of 20 degrees, the normal reaction is perpendicular to this inclined plane. So the normal reaction is no longer mg. And we have learned earlier, the normal reaction is mg cos theta. And in this case, the theta is 20 degrees. So we have normal reaction mg cos 20 degrees. So this is the normal reaction of the surface. And if we include the coefficient of friction, the frictional force will be, or the kinetic friction will be 0.21, which is the coefficient of friction, multiplied with the normal reaction on the inclined plane, mg cos 20. So finally, we have found the kinetic friction of the inclined plane. But that is not all. We need to know how how far this skier travel along the horizontal plane, because this is the distance that he is exposed to the frictional force. It is not the vertical height that he is exposed to the frictional force. Okay, so the vertical height cannot be used to find the work done against friction. The vertical height can only find the potential energy, but not the work done against friction. Work done against friction, because the frictional force is acting along the surface of the inclined plane, so you have to find the distance along the surface of the inclined plane. So now we're going to make use of the trigonometry. Okay, so the height here, h divided by the distance along the inclined plane, which is the hypotenuse of this triangle. H over d is sine 20 degrees. This is 20 degrees. So the vertical height divided by the hypotenuse is sine 20. So how much is the hypotenuse? The hypotenuse is 20 divided by sine 20. And it is 58.5 meters. So this 58.5 meters is the hypotenuse of the triangle. It is also the distance traveled by the skier when exposed to the frictional force F1. This is the distance. Okay, next. We're going to talk about the horizontal distance. This horizontal distance, the skier is exposed to frictional force F2. F2. F2 is different from F1. Why? Because the normal reaction when the skier is at a horizontal position, the normal reaction is mg. Earlier on, along the inclined plane, the normal reaction is mg cos 20. But along the horizontal surface, the normal reaction is mg, the full component of the weight. So how much is the frictional force F2? Mu n. Mu 0.21. Normal reaction is now mg. Okay. So far, any question? The geometry of
No
the
question.
no question. The geometry, okay. Geometry part, okay. Then we're going to look at the work energy theorem. Work energy theorem says, oh, the loss in potential energy. The potential energy is converted to the work done on the friction. Work done on the friction. How much is the potential? The potential energy used up. The potential energy is mgy. M is the mass, g is the acceleration due to gravity, y is the height. Height is 20. Okay, height is 20. Now this potential energy is used against the friction. The work done on the friction got two parts. One part is the inclined plane. The second part is the horizontal plane. So each of them, they move through different distance. They possess different frictional force. So we're going to look at the inclined plane first. Along the inclined plane, the frictional force we have calculated earlier here, 0.21 mg cos theta. And the distance along the inclined plane is 58.5. Frictional force along the inclined plane, distance traveled along the inclined plane. Then another work done will be this one. Frictional force on the horizontal plane and the distance traveled along the horizontal plane. Frictional force 0.21 mg, we have found out here, 0.21 mg. Distance traveled we don't know, we leave it as d. Distance we don't know, we leave it as d. So now you have to solve this equation. All these, they are numbers known. Only the d is unknown. So we have to solve for the value of d. So the value of d is 40.26 meter. Any questions so far?